Okay, here we go, let's begin. Exercise 7G. You've learnt transformation, 7A, B, C, D. Dilation, translation, reflection. And combinations of all that. So that's 7A, B, C, D. Yeah? Then we came back this term, we did E and F in the last two sessions. Okay, so E was to introduce add, subtract, multiply. And then I showed you how to multiply matrices as well. That was the hardest part of E. In yesterday's lesson, I showed you that because you can't divide matrices, I showed you a technique where you times by the inverse. That's what you were doing today. Okay, so this sheet, the first session of today, you were practicing E and F. Now you're going to combine all that together, A all the way up till F. You're combining your understanding of matrices with what you understand about transformations with coordinates. So remember how I showed you how to read transformations like this, where it's x, y maps onto, let's say, x plus 1, y minus 2, and that was the translations you had to know. That means to the right by 1, down by 2, okay? It's the same thing, now it's just in a matrix form. Exactly the same thing, okay? So, here we go. Let's think about this. This is what we started off with. We had, yesterday's lesson, we had A times the matrix X, so matrix A times matrix X gives you B. Now, you can think of it, if it happens to be in this form, and in this whole exercise is going to be in this form as well, X will be a 2 by 1 all the time, A is going to be a 2 by 2, and your ending results will always be a 2 by 1. Okay, so this is a 2 by 1 column. So, this is what we have. This is a 2 by 2 multiplied to a 2 by 1, and the ending result will be a 2 by 1. Okay? The reason why this is nice, and why we're going to use this, okay? Why we're going to use this to our advantage on coordinates. Because notice I called this X and Y. Those are your X and Y coordinates. The first row represents your X coordinates. The second row represents your Y coordinates. Now if you look at this equation here, AX plus BY and the TX plus DY, it looks very confusing. But what if I change it and look at the next one by comparison? All I've changed is I've made B and C zeros. If I made these zeros, okay, if I ask you to multiply what you've learned in E, you'll do A times X plus 0 times Y, ends up being just AX. If I told you to multiply 0 with the X and then D with the Y, you end up with DY. Now this is cool. Why is this cool? Is because this now represents your X and Y coordinates. This represents what you're going to multiply to the X and Y coordinates to get this, which is your new X and new Ys. So another way of thinking about it is I'm saying XY maps to AX dy. That's exercise 7B if you've forgotten dilations. So remember this value here, if I change that to be a 2, 2 ends up multiplying to X. And I end up with 2X. Now 2X, now you can say, well, 2X means I'm stretching all the X values horizontally. So it's dilation of factor 2 from the Y-axis. Remember that? Remember those terminologies? Away from the Y-axis. So this is dilation of factor A from the Y-axis, dilation of factor D from the X-axis. Okay, so we're linking 11B with the matrix form. So whatever I put here, and these two spots there, these will represent the dilation factors. And this is nice because now we can use matrices to represent a transformation. That's why they're called matrices or matrix transformations. Okay? And we're going to learn in this exercise just to read dilations and reflections. In fact, they don't teach you translations until next year, but I can easily show you translations at the end of this whole entire slide. Okay, because it's very easy to add on, because translation was add and subtract. So how do you add and subtract matrices? It just has to be the same dimensions. So if you wanted, you just need to add on a 2 by 1 and you're done. If you add on a 2 by 1 matrix, that becomes the translations. Okay, but for today, we're just going to do dilations. We're just going to look at that matrix. This X matrix represents your original X and Y coordinates. The ending result represents the transformation that you've done, so you can read from it. This will tell you dilations. Okay? So let's do an example, just to get your head around this. Let's say I gave you something like this. This tells me that I've started with an x, y coordinate. I'm going to multiply it to this matrix. We're going to use what we learned from exercise 7E, multiplying matrices. Row 1, this is a 2 by 2, multiply to a 2 by 1. Can you multiply them? Yes. Rule 1 says you can. Ending result should be a 2 by 1. So the ending result should end up being a 2 by 1. So 2 rows, 1 column. So we follow it. We go 3 with the x, 0 with the y, and that's what I've done here. 3 times the x plus 0 times y. That gives you 3x. If I follow the second one, row 2 times column 1, you do 0 times the x, negative 2 times the y. And that's what I've done over here. That now gives you negative 2y. But if you actually read it, so I went from x, y coordinates, that's what I started off in red. Okay, that's what I started off in red. I'm going to just delete all this again. I started off with x and y. And now, after multiplying it to this matrix, I end up with 3x minus 2y. So if you actually read that, if I ask you from exercise 3C or 3D, I mean 7C or 7D, what's the transformation telling me? What's a 3 here tell me? Yeah. Dilation of factor 3 from y. Good. Because it's all the x values are getting stretched. So you're multiplying all the x, so that's away from the y. If you're multiplying a factor 2 to the y values, it's from the x. What's a negative do again?
Yeah.
Oh, no.
Upside down.
That's only if you minus something. If you times it by a negative, if you have a negative times a y, what does that do again?
Wait.
No. If you want to go up, you would have plus 1, that would go up. Minus 1 will go down. But what happens if you multiply by negative 1? It's a, no, not thin, reflection. Remember reflection, you had dilation, reflection, translation, reflection. What does reflection do? So remember, if you have a mirror on the x-axis, this coordinate will flip. So reflection is a flip. Yeah. So in this case here, when you put a negative on the y, all the y values now become negative. So it's a flip. Okay, so if you were to read this, this is dilation of factor 3 from the y, dilation of factor 2 from the x, but also a reflection in the x. Because that's, you're changing all the y values to become negative, so you're flipping over the x. So we call that reflection in the x. How's that feel? Yeah, because that's all you're really doing. This whole exercise, you can either do what I just showed you, getting you to read it, or you can do what I don't want you to do. I don't want you to memorize that. Okay? There are too many things to memorize when the logic to it just makes sense. You see, all this is just a description of what you have. When you have a negative y, of course, you're multiplying negative 1 to the y values. That's why it ends up being a negative y. That's just a reflection in the x. Reflection in the y, dilation factor, reflection in the x. Okay, so I don't want you to memorize all this, but if you find it hard to read, copy this down. Okay, so I want you to copy that down just as part of your notes to refer to, but I don't want you to memorize that. I want you to be able to read the transformations, because that's all you're doing today. Yeah, all they're trying to do is get you to read those. How does that change things? That's all you're reading. So there's no translations at the moment. It's just dilation or reflection. So reflection has negatives. Dilation is when you're multiplying by a value. Okay, so if you just think about it, put an x and a y coordinate here, 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 and we actually did your multiplications like I taught you for 7E, you'll get the answer on the left-hand side. See, if I actually multiply it, this will end up being x negative y. If I multiply it, it ends up being negative x positive y. If I multiply this one, this now becomes kx positive y. If I multiply these two, this becomes x ky. If I multiply these two, 0 times x is 0, and then 1 times y, so this becomes y, this becomes x. And all of that on the right-hand side that you're using 7e to multiply these coordinates, that's just a description of what's over here. That's what I'm saying. You don't have to memorize all that. It makes sense. If you multiply negative x, you would tell me reflection in your y-axis. Times x by k value, you say dilation from the y-axis. Times y by k, you would say dilation from the x-axis. When the x and y switches, you would say it's a reflection along the y equals x. Okay, the inverse function, reflection along the y equals x, you're switching x and y's. Okay? So you have those 5 different matrices. I prefer that you eventually don't memorize this, but that's the logic. That's the logic. We're going to do some examples to get you thinking and how to do the questions. Okay? So copy that down. Make sure to copy that down because we're going to use those matrices for the next one. And I want you to be able to read them exactly the same way as 7B, 7C, 7D. Just using matrices. Which one? In the red. All of them? Right. I'll do it in blue. I'll just erase it. I'll do it in blue. Tell me if this is clearer. Or is that worse? Okay. What if I did it in black? Is that worse? Or do you prefer red? Yeah? You think? That looks a bit light.
I can't see anything.
Yeah.
I can see the first three black guys.
I'll do black.
I'm not playing anymore, guys. Bye. That negative X. No one?
Yep.
What's the one?
X negative Y.
Everyone. One person has chances are like one person. Someone's probably going to walk out. No, someone's going to go all in. Probably. No, you're going to start losing it. That's why they did betting this year. No, I didn't. The first and the second time I had like 7,000 credits. I went all in. I got I figured it out.
Oh yeah?
I figured out 7. I was so confused and I realized I did everything wrong.
Oh.
And I tried to fix it and I realized I did everything wrong again. But in doing so, I realized what I did wrong. So now I'm going to
Yeah, exactly. That's how we learn. All right. Next one. Let's do this example here. You finished?
Yeah, but my last answer, I got everything right except that was meant to be 12. Everything else was the same. I don't understand anything about that.
Let's just check. That's right. That's correct. So now, to get rid of A, you have to times A universal.
Yeah, that's what I did.
You don't have to times the 1 on 10. You can leave the 1 on 10 over here.
I just left that. I didn't use it.
Okay. Well then, Should be alright. So 1 times the 6.
6 and negative 3 times negative 2 is negative 6.
Well, just to make sure that A inverse was correct. Yeah, that's right. Okay, so 1 times 6 is 6, plus 6 is 12.
Oh.
Negative 3 times negative 2 is 6.
Yeah, alright. Alright, well, I'm just gonna...
Thank you. Alright, guys. Let's begin. Here we go. Let's do the next example. Listening. Quiet down. Ian. Alright, here we go. Find the image of the point 2, 3. What they want you to do is not to use what you learnt in 7B. They don't want you to do this. They don't want you to go 2, 3 and find out the new X and new Y. They don't want you to do that because you already know it's reflection in the X-axis, which means reflection in the X-axis means that it has to be this type of transformation. Reflection in the X, mirror in the X, so all the Y's become negative. So it should be X minus Y. So that means if you sub in 2, 3, the answer should be 2, negative 3. But we don't want that. Okay, we don't want you to use what you learned from 7B. We want you to combine that with 7E and 7F. So how do we do it? Same thing. We had AX equals to B. Well, you can think as B as the new X. So I'll use X dash in case if that's what you prefer. This will now tell me I've got a 2 by 2. I've got a 2 by 2 with X, Y equals to X dash, Y dash. Now I'll put 0, 0 because on the last slide, remember these are all zeros. 0, 0, 0, 0. Okay? What I'm asking you now is, what was the matrix to have reflection in the X-axis? You knew it had to be a negative Y. The only way to get a negative Y is if this number here is a negative 1. Because negative 1 times Y will give you that negative Y that you want. Okay, so instead of memorizing that matrix, instead of memorizing that last page, I didn't want you to memorize this page. I want you to figure it out. This had to be minus 1 here, and that was a 1. Okay? So that's what I want you to understand, that this had to be the negative to get that reflection that you wanted here. That's a negative 1 times Y. So this has to be a negative 1 times Y. This is 1 times the X. That's why it's 1X here. Okay? So then, once you've got this, you can now apply your coordinates. Now you can say 1, 0, 0, negative 1 multiplied to your coordinates, which is 2, 3, and work it out. So let's work it out. X dash, Y dash. Use what you learnt in 7E, multiplication. This is a 2 by 2 multiplied to 2 by 1. So we do 1 times 2 plus 0 times 3. So 2 times 1 is 2 plus 0. That means the top value has to be 2. Let's do row 2, column 1. 0 times 2 is 0. Negative 1 times 3, negative 3. So yeah, result would end up being 2, negative 3, but you've just used matrices to read the transformation. Okay? If you want a neater sort of, if you wanted to neater version, that's your neater version. So that's 1, negative 1. Okay? So you can see all I've done is I've just said, since we know it's matrix times the original X coordinate, to find out the new coordinate, I subbed in, I figured out that that had to be 1, negative 1. That's the only skill you're learning here. Instead of memorizing, I want you to figure this one out. Once you know that, multiply what you've been doing in your worksheets, get your answer as 2, negative 3, and that's the new coordinates. That's the image. Okay, so I don't want you to use 7B anymore, I want you to use 7E to figure it out. Same thing with the next one. It says dilation of factor K from the y-axis. See, from the y-axis, if you're moving away from the y-axis, what values are you affecting? Is it the x or the y's? The x. Okay, because you're moving horizontal away from the y. This is your horizontal x-axis, so you're affecting all the x values. Whereas this one is from the y, from the x-axis, you're affecting all the y values because it's vertical. Yeah, so if I got these coordinates, I said times 2, it goes that way. So that's away from the x, but you're affecting the y values. Okay, affecting x, affecting y. So this one tells me that the matrix xy, to get to the new x, new y, I have to multiply the dilation from the y-axis. I have to multiply the x values by k. So that has to be k, and that has to be 1. Okay, so that's where I want you to be able to figure out. I don't want you to memorize them. I want you to know k times x will give me that kx I want, and 1 times 1 will give you the 1y. Okay, so instead of doing 7b, see 7b, you would have done this one. You would have said xy maps to, and you would write kx and y. That's what you would have done for 7b to represent that. I don't want you to do that anymore. Now we're doing the other way around. We're doing 7e. So you got to lay it out like this. Then you say, all right, k0, 0, 1 multiplied to the coordinates 2, 3, and you want to work out what x dash, y dash is. That is where you use 7e to multiply two matrices together. So here we go. We got k times the 2 plus 0 times the 3. And then row 2, column 1, so 0 times the 2 plus 1 times the 3. And you can see the answer ends up being k, 2k, and 3. Okay? And that's your x dash, y dash. And that's exactly the same. It just looks different. That's exactly the same as what I wrote up here. Okay, so 2k is if x was 2, y is 3. Okay, you would get 2k and 3 just the same way. It's just matrix method, linear method. Okay, same idea. That's all you're doing today. How do we feel? Pretty good? Yeah, that's matrix transformations. One last example, just in case you get to this kind of question and you find it difficult. I'll do this example and that's it. That's the last example, and that should summarize everything you need to do 7G. Okay? Let's read this question together. Consider a linear transformation. You've got the coordinates from 1, 0, and it ends up being a 3, negative 1. So we don't know what the transformation is so far. We just know if I have a 1, 0, it becomes 3, negative 1. If I have 0, 1, it becomes negative 2, 4. What they want you to find is, what if I have a negative 3, 5? What does it become? So your job now is you have to figure out the transformation. So in the last slide, they told you the transformation. This job now, you have to find the transformation. So how do you do it? Same drill. It's exactly the same drill. It's still AX equals B. I don't know what the transformation is. So it's A, B, C, D. I don't know what that is. I don't know if it's 0, 0. I don't even know that. All I know is it's going to be a 2 by 2. I know the original coordinates. They told me it was 1, 0. When it was 1, 0, it ended up being 3, negative 1. My goal is to figure out A, B, C, D. But the nice thing here is you can use 7e to multiply these two. So if you multiply it, it'll be row 1, column 1. So A with a 1, B with a 0. Now anytime there's a 0, it's wonderful because it cancels out the letters. So if you try this one out now, you do A times a 1, B times a 0. You end up with B times 0 cancels out, and then the bottom one, D times 0 cancels out. You end up with, wait, let me just cross that off. And this is nice. Because what you just figured out just by laying it out like this, multiplying using 7e, you just multiply A with a 1, B with a 0, C with a 1, D with a 0. You end up with AC equals to 3, negative 1. So now you know A has to be 3, C has to be negative 1. And so that's nice because out of this matrix here, you just figured out half the equation, or half the transformation. So if you do the second part now, you do the exact same thing. You say, all right, what if I had 0, 1? It ends up being negative 2, 4. But the nice thing is you already figured out A and C. You do the same process again, times these two to find out B and D. Okay, so the question was designed so that it works out this way. Usually it doesn't work out this nicely. Okay, so you multiply that, same thing, you find out that BD, you multiply 3 with a 0, cancels out, B with a 1, stays as B, D with 1 with a 0, cancels out, D with a 1, stays as D. So now I know B is -2, D is 4. So now I know the transformation. I know what A is, I know what B is, I know what C is, I know what D is. I can figure out the last equation. See, the last one they said, well, what if your coordinates now is -3, 5? What's the final? That's what I've done. If the coordinates was -3, 5, I already figured out A, B, C, D. I can figure out the final images by doing, again, 7E. Okay, so 7E multiplication of matrices. 3 with a -3, -2 with a 5, -1 with a -3, 4 with a 5. Add them together to get your answer. Okay, so I'll just give it out. Here we go. These are your answers, -19 and 23. And that's just telling you that you transform -3, 5 to -19, 23. That's effectively what we're saying. Okay, that's 7G. Ties everything you've learned together. Transformations A, B, C, D, matrix C, 7E, and F. Cool? You got your time now, about 20 minutes to complete this sheet. If you haven't, from what I've seen, most people are up to the last page. Finish this off, hand it to me, and you got your 7G to work with. Okay? Yes, you do. I want to look at your working solution. So I know 7E and F is good. 7E and F. Yeah, I said that. Stop. Did you throw it in the bin?
No, I just drew some drawings.
Oh, that's all right. What kind of drawings?
Some fake family friendly ones.
Okay, cool. It's not shameful ones. That's cool. Maybe I'll draw something along with that. I'll draw a cow. I recently learned how to draw a cow. Yeah, I'll show you. Here we go. I'll draw my cow. Here we go. I've been practicing. It was my homework, apparently. My year 7 gave it to me. Here we go. I'll draw a cow.
All this face. Very good. I see it already.
Oh, you see it already?
Yeah.
I know. It's a very impressive cow. Maybe I should give it a tongue. Oh, yeah.
What?
Oh, yeah. And then my infamous... There we go. That's my infamous signature there. Every birthday card since year 7 all the way to now, and every wedding place that I've been to. Like, you see that picture? That's from me. That's my tag with my signature, and that's why my year 7s gave me a homework. What's a cow? So I went home and I practiced a cow, so it's my cow. That one I've been drawing since year 7, so it's very fluidy and easy. There we go. Yeah.
What are you signing? What does it say?
It's my signature. But you're not meant to know what it says.
Oh.
My friends will know what it means, but...
Jerry.
Jerry. Oh, I should stop the video, actually. Now it's all recorded.